आपको दिख रहा है बोर्ड? चलो बिस्मिल्लाहिर्रहमानिर्रहीम. So today we talk about what? So we have seen the push down automata, right? Again the same thing happened. I need a pen. So we have seen the regular languages, right? Which come from the regular grammar, which generates regular languages, and we have the finite state machine, okay? Which the automata we have is the if we have regular grammar, with the regular languages, the automata which accept it is the either DFA or NFA or epsilon NFA. Okay, NFA with the epsilon moves. Now the problem with this guy is we have a very limited memory. We have what? So if we have limited memory, we cannot work with many languages which need memory, right? For example, if there is a raised power n, language is having a raised power n, there is no issue, we can do that. We have an state, this is the a, it comes here, this, accept it, many times a comes in, no problem. But if we have a raised power n, b raised power n, and because we have to ascertain that how many a's, that many b's. अगर a 2 है तो b भी 2 होने चाहिए, अगर a 3 है तो b भी 3 होने चाहिए, right? We have to ascertain that thing. We are stuck with this. Why? Because if we start making this, because this is infinite, it needs infinite states, okay? It's not possible to visualize it. Using the regular language, we are not able to have an automata which accept this language. We will see it in a moment. So therefore we need something powerful language, right? So we said we have the context-free language, which comes from the context-free grammar, generated by context-free grammar. And this context-free grammar is accepted by the automata, which is, now this push-down automata is more powerful automata, okay? It's the more powerful. But it is actually the same, this DFA or NFA, right? Or epsilon NFA, right? With some memory. Only thing we are doing is giving more memory to it. Because this was having short, the regular, the DFA, the finite automata, was having a very limited memory. So it can't work. Now we are going forward a little bit. So it's that NFA, what we have, plus the stack. Plus what? So we are adding to the same DFA or NFA. I am adding stack to it. I am adding what? So that's I am giving more memory. Now this stack can be infinite. We have to give infinite stack, right? Such that we can check out about these languages. You can accept these languages, right? So it comes in the type. This is 0, type 1, this is type 2, this is type 3. It comes in a type 2, context-free languages, which come from context grammar. And the automata which accept it is push-down automata. So what is push-down automata? That is our lecture today actually, right? Okay, so this is what I said, that our PD is actually the same NFA with the epsilon moves maybe, you're adding a star. Okay, so transitions are modified according to stack operation. So now when we do transitions, because we have the transition, right? Now the tuples we have, like we have 5 tuples in case of our DFA and all. Now we may add, we have to take into account the stack also, right? So that is shown by the gamma, the capital gamma, right? This is the capital gamma. You may have seen the small gamma. This is the capital gamma. It's the same gamma. We use the gamma symbol to see the stack elements. What is on the stack? What is on a? So now my transition will not be like my transition was initially that I was on a state Q and I have some input A, right? But I also have to talk about now the stack. I have to also talk about what? So my transition will be on the basis of 3 things: the current state, the input, and the stack. So what is on the top of the stack? right? We know what is stack and how does it help, right? So DFA में only finite amount of information थी क्योंकि हमारे पास memory कम थी. Now we have infinite amount of memory in terms of stack. That is the difference, right? Getting? Okay. Now this is our DFA. We try to create, but we can't do this 0 raised power n or 1 raised power n with the DFA. We cannot do that. But we can do this thing. That if we limit this n to 3, for example, here in this example k is what? 3. I am limiting n to 3 and I want to design an input which has, say for example, 0 raised power 1, 1 raised power 1, or 0 raised power 2, 1 raised power 2. So this is 0 0, this will be double 0 double 1, right? So if it is 0 raised power 3, 1 raised power 3. So we have triple 0 triple 1. If this is the language, I have to accept it, right? Now imagine if we want to do to the n times. So we have to have tremendous amount of states which is not possible to design in the DFA. Now let us try to see how we can do this in the DFA. We start with this initial state, okay? Nothing comes except it because n is 0, for example, if n is 0, 0 is for 0, 1 is for 0, that's no zeros or no ones, we can accept it. If single 0 come, we can't accept it, go to the next state. If 0 comes and 1, 1 0, 1 1 comes, so accept it, right? If anything, then again the 1 comes, it goes to dead state. If it starts with the 1, we cannot start with the 1, we have to start with, so it goes to the dead state. This is your halt state, dead state, okay? And now if the double 0 comes, then double 1 comes, accept it. If 3 0 comes, and after that 3 1s comes, accept it, right? So we can design this way. But the thing is that if we have n times, right? So we need n such, we need a lot of states, and it could be, and it could be anything, right? It could be 10,000, it could be 20,000. So it's not possible to, because we don't have such a memory in the DFA. So we cannot design this thing using what? DFA. So therefore this is not a regular language. But if we limit k, okay, if the k is fixed, whether k is some 3, 4, 5 or something, we can design it, but not for the, if it is not defined, if the k is not defined. Getting the point? Everybody got the point at this point? Nasıl? वो ना सुन वीडियो ना 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 ट्रैश ठीक असो वक्त को जाने चलो जाने को स्कर्स तो मैंने से ये यहाँ ये accent से activity logs नहीं क्या activity logs में क्या मोकलियो ना ट्रैश में मोकलियो पाचन का चांस ही का getting the point? So this is what? This is what? This is a DFA. So you can imagine if we have the 0 raised power n, 1 raised power n, it's going to be infinite number of states, so this won't help us, right? So therefore we need to have some powerful automaton, which is my push down automaton, right? I don't need to do that. Sometimes happen these things. Okay, now we go here. Now tell us about this slide. Can you understand this? ये पीछे गया कि आगे गया? So each in DFA में हर एक स्टेट जो है ना फाइनाइट अमाउंट ऑफ इंफॉर्मेशन है, ठीक है ना? जब आपको 0 पर n और 1 रेज पावर n है, ठीक है, उसमें इनफाइनाइट नंबर ऑफ स्टेट्स चाहिए होंगी, जो पॉसिबिलिटी नहीं है. ओके, सो अगर हमारे पास इनफाइनाइट स्टैक आ जाता है which can hold the things, we can manage it, right? So the simple thing, if I show it very simply, very subtly, this thing is, if I have, for example, I want to see if I have 000 and 111. Okay, let me show it very subtly. Firstly, if I have 000 and 111 and I want to chuck कि घसना बराबर zeros बराबर होना से, what I do is if I have a stack and I put it on something z0 maximum book shows, some book shows hash, some shows dollar, so it's up to your choice what you put. This is the bottom of the, and this means end of the stack. This means what, जिस तरह हमारे पास एक पॉइंटर होता है ना टॉप, उसमें किसमें डेटा स्ट्रक्चर में पढ़ा था, टॉप होता है जो स्टैक को पॉइंट करता है. So if top hits 0, so it's an end of stack. Here we put up z0. We put what? Or hash or some symbol, which specifies that there is nothing left. Okay. If the 0 comes, push it on the stack. Another 0 comes, push it on stack. Another 0 comes, push it on. 1 comes, pop it. 1 comes, pop it. 1 comes, pop it. What is now? So that means this string will be accepted. It belongs to 0 raised power n, 1 raised power n, because here n was 3. Okay? If maybe I have one more 1, if I have what, we should not be accepted, right? Now input तो भी खत्म नहीं हुआ ना यहाँ तक, हमारे सारे 0 खत्म है. अभी स्टैक क्या है, empty. इस 1 पे तो अब इस 1 पे कोई पॉप करने का कुछ है नहीं, है ना? So we'll say कि ये balancing, so we do not accept it. So simple, using a simple stack, we can do it very easily. If we try to do it in the DFA and all, we have a complex set of states. We have to make a complex set of. Here with the help of stack, it will be solved very, very simply. Like we have the palindrome, na? WWR means you go this way or this way, reverse order, it will be same. That's called palindrome, na? Say for example, we have 0, 1, 0, maybe we have 1, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, 0. Do you go this way or this way? So to design the DFA for this, it will not be possible. Okay, but if we use the push down automata, it will be very easy, because we have the additional what, the stack. We have the additional. So this is what I'm saying, read all zeros and place them on a stack, and read all ones and match with the corresponding on the stack. So only 2 states, we need only how many? Even though we have n is infinite, no problem, only 2 states. Okay, if it is 0, go on a stack. If it is 1, pop, and that's it, right? So we have only 2 states. We have only what? You getting my point? So it will be like if we have, but we have epsilon and all for that. We will see later examples, more examples to understand. But typically, if we have 0, it goes stay on a stack. If it is 1, if it is, then you have to pop and all and check for the z0. Then you can accept it, right? Otherwise, you cannot accept it. So typically, we will have only how many states? 2 states only. We are only getting. Now, how you formally define the PDA? How you? This will be the this can come in an exam, right? How you formally define the PDA? What is PDA? Okay. How many tuples we got here? 7. The Q. The Q is the same. The finite set of states which was in our DFA is the same, right? Again, the sigma. What is sigma? Finite input alphabet. Whatever the alphabet. Like in our previous example, our sigma was 0 and 1, right? The alphabet. Oh, hello. दिमाग रखो यहाँ पे. ठीक है? Now, what is the gamma? A finite stack alphabet. कि stack में क्या जा रहा है? Stack में, because we do not need to only the inputs, we also need to see the stack, right? So stack में क्या जा रहा है? Those things are the part of what? The gamma. Q0 initial starting state, the same as in the DFA. It has to be from the Q. Initial state has to be from Z0. A start. I told you you put up in a stack Z0, right? But some books write hash or dollar or something. So what is Z0? A starting stack symbol is in gamma. It has to be in a gamma. So gamma में जो भी होगा पहला उसमें क्या होगा Z0, which we put on a stack. You understand that? Alia? You getting this? So Z0 will be initially what we put on a stack is the Z0 with the first input letter. When the first input letter comes in, first we initialize the stack with the Z0. Okay? It means this, because when we pop and we find the Z0, that means stack is empty. To understand the stack is empty. You understand that? Like we have the top and we pop and it moves to the 0. We say if top equals to 0, so stack is empty. So we have to use here the Z0. When we pop and we got Z0, we pop it Z0 from this. That means what? Stack is empty. So that is your Z0. What is F? The set of final accepting state, which is subset of Q. Because we know the F can be all the states of Q or some states of Q, or even a single state from the Q, which has to be the final state, right? And then the transition function, lambda. A transition function where we have this is the transition function. So what is this? Let us try to understand this. Okay, what is this transition function? This transition function says this is our initial thing and this is our final thing. Okay, initially we were here and we do transition to go here, right? So initially we were on the Q state, okay, and I was on a Q state, for example, and I am taking some input A. I am taking some input. So you are in a transition state, you are in some state, okay, and you took input. Where from you took input? From the alphabet, from the, so you can take any input, है ना? चाहे अगर हमारे पास input दो है, 0 या 1, so you could took either 0 or you could took either 1. Maybe I have the A comma B as our alphabet. Maybe my alphabet is A to Z. So it could be any input. कोई कुछ भी आ सकता है ना, A आ सकता है, B, C, D, कुछ भी आ सकता है. Does it make sense? So we are saying that we are on a state Q and we are taking some input from alphabet, from some, what is this sign called? You tell me. No, this sign. Sigma. Sigma is for the, what do we alphabet means? Inputs. Whatever inputs we have. Okay. So we are saying we are on a state, some state, and we got some input, right? In DFA, what do we do? In DFA, we are on state Q. We get some input. We go to the another state Q2, right? The same is here, but it is saying not only the input alphabet we have to take care of. Union epsilon. Union epsilon means sometimes you may have no input. You may have what? That means you are on a Q state, you have no input and you are going to Q2 state without any input. That means your epsilon moves. That's what? So epsilon moves are allowed here, right? So this is an app. That's why I said that PDA is the epsilon NFA plus stack. So your PDA is actually epsilon NFA plus stack. That's what I say. That you may have no input but you have epsilon. Union of it. Maybe input is absent, you have epsilon only. Or you could have any alphabet from the alphabet, any input. Okay? You are on a state Q and you are receiving some input. Or you may receive epsilon. But not only that, you have to also see what is on the top of stack. What is on the, shown by the gamma. The gamma will tell you what is on the stack. The gamma is telling what is on the stack. So you don't have to only see what you are receiving, but you have to also see what is on a top of stack. So, and what will happen? You will get some another state. You will go to some another state. After receiving some input, okay, after receiving some, so we are technically saying, if I explain it like this, you are on some state, let it be Q, okay, you are receiving some input A. This A should belong to, that is what we are saying, that you are on some state Q and you are receiving some input from the sigma, or you may receive nothing. It could be the case, could be like this, that without input you are going to some other state. That means you are receiving epsilon. If you are not interested, you can go. Rasya, you listen to me. Next time I will not, I will kick you out of the class. This is last warning for you. Now, with that, you not only have to see that, you also have to see what is on the top of the, maybe there is some A or B or whatever is on the stack. We'll see when you see examples, you will understand. What happened to this? The power is gone. Why is the power gone? Oh, वो power आ गया ना तो ये भाग गया. Basically वो वाला power आ गया. Okay. सर्दी लगी. Listen to me. I'm not telling you again. This is bad. I'm not telling you again. I have seen enough of you now. Huh? Light? Today we had a lot of distraction. कौन सा ये? This was solar, na? Actually, when light comes, it gets off automatically. This is what happens to it. Anyways, so we are saying, चलो इधर आ जाओ. इधर आगे पूरा. So what we are saying is that we want to go from one state to other state. That's what transition function. So transition function is a little bit complicated here. Why? Transition function is saying that you do not have to see only what is the input coming. You have to also see the stack, what is on the top of the stack. Now, depending upon that, you go to the next state. So what will be on the right side? You go to the next state, and also you have something to push onto the stack. You don't have to only pop from the stack, you have to also. So left side say what is on the stack which you want to pop, but right side says which state you will go, and also what will you push on the stack. Getting? Okay. It was in which one? Oh, MOV. Yeah. That's basically it's not visible because it's a Mac. Which one was this? Huh. Okay. Here we are, right? So not only you go to another state, but you have to do something which you are going to push on the stack. Again, we're talking about stack, right? Okay. So it means the things are happening like Anwars are coming, like the power supply and Rasiba yarning all the time here. So it means end of the day. So call it a day. Thank you.